Hello, this is the luckiest maths teacher in the world. Now today we look at area. So we've already looked at perimeter. So perimeter, which I'm just going to write with a P, that is one dimension. So you're looking at length. So like the length of, say, this line here, that's in one dimension. Area is of 2D shapes. They have two dimensions. They have a length and width. So they go in this direction, but they can also go in this direction, okay? So for example, that's just a triangle. So when we're talking about area, when we're looking at the area of a shape, we're looking at how many square units can fit inside the shape. So unit is just, what we were talking about last time, millimeters, centimeters, or whatever. So area is how many centimeters squared can fit in the shape, or how many millimeters squared can fit inside the shape. And what we mean, of course, by a square unit, so one, say, millimeter squared would be like a square, of course. That is 1 millimeter across, so that 1 millimeter in that dimension, and 1 millimeter in another dimension. So this square here that I've written is 1 millimeter squared. So in area, we're thinking how many of those could I fit inside a shape? So we're going to look at three shapes: rectangles, triangles, and parallelograms. So let's look at a rectangle. So let's say I have this rectangle here and I want to find its area. Now, I could go through and I could count each of these squares, these square millimeters, and just tell you how many were in there. But of course, we don't want to do that all the time, because sometimes the shape will be too big, but that will just take so long anyway. So what we have is each of these rows, if you go across and I count just this first row, there are 12 squares in each row going across. But you can see there are 1, 2, 3, 4, 5, 6 groups of that. So this side here is 12 millimeters, because it's 12 millimeters along there, by 6 millimeters. So to find how many squares can fit in, if 12 go this way and 6 go this way, then groups of just means multiply. I can just multiply them together. So the area of this rectangle is 12 millimeters by 6 millimeters, which is 72. Now, the way you write it is you write the unit, but you write a little 2 there, which means squared. So the area of this shape is 72 millimeters squared. In other words, I can fit 72 little squares, each of which is 1 millimeter squared. I can fit 72 of those inside the shape. So the general formula for the area of a rectangle, so that's the area of a rectangle, is just the length times the width. Now, because we're timesing and the order doesn't matter, it doesn't matter whether we say this is the length and this is the width, or vice versa. It doesn't matter in this question whether we say L is 12 or L is 6. Okay, so a lot of areas just substituting in formula, which we did in algebra. The area of a square, however, a square is just a type of rectangle, but in a square, the length and the width are the same. So we can just write it as L squared. It's just the length squared. Okay, so let's now look at a triangle. So copy this down if you like. So let's now look at trying to find the area of a triangle. Now, we could try and count the number of square millimeters that are in this shape, but of course, again, that takes long, and that'd be pretty hard for this shape, because sometimes like only a little bit of the square is inside the triangle. But what we can do is use our knowledge of rectangles. Now, any triangle you get, you can rotate it in such a way that the base, like this, lies nice and flat. Now, for any triangle, doesn't matter what type of triangle it is, you can always draw a perpendicular line, so at right angles, from the base to the top of the triangle. Now, what we can see, though, is that we can make these into rectangles. So I'm going to make a rectangle here in red, and I'm also going to make a rectangle in green. And this rectangle encloses the triangle. And I apologize that I can't use a ruler here. Now, what you see is that I have two rectangles here, one in green plus one in red. So I'm going to say, let's let the length of the base of the triangle be down here from L So from here to here be L. And then the width I'm just going to call W from here to here. Again, it doesn't matter if you do L and W the other way around. So what you can see is the area of the whole rectangle, I'm going to draw that in black. So the area of this shape here, this rectangle, all the way around here is L times W, right? But what we can see is that in the red rectangle, the part of the shape that is inside the triangle is half of the rectangle. So half of this red rectangle here, half of it's inside the triangle and half of it is not. Similarly, in the green rectangle, half of the shape is inside the triangle, half of the squares are inside the triangle and half are not. So what that means is that the white triangle is half of the big black rectangle. So the big black rectangle was L times W. So the area of the triangle is going to be L times W, but divided by 2. But usually we just use different letters for the triangle. So we use B for base and H for height. So the area of a triangle is base times height divided by 2. So it's exactly the same as finding the area of a rectangle, but you have to divide by 2 at the end. Now, whenever we say H, the height of something, we always mean perpendicular. So I'm just writing perpendicular. So we've been through that this year before. So it has to be the height that is 90 degrees to the base. So let's go through an example. So let's say I have this triangle here, and I'm telling you the base is 12 meters. Now the slant height is 8 meters, not the perpendicular height. The perpendicular height is 5 meters. So we only use the perpendicular height in the question. So to find the area of this triangle, it's base times perpendicular height divided by 2. We don't worry about 8 because it's the slant height. So 12 times 5 is 60 divided by 2 is 30. And because all the units were meters, the answer will be 30 meters squared, okay? So now we're just going to do a couple of problem-solving questions, then we'll get on to parallelograms. So please copy down this example if you need it. So you might have to solve a problem like this. So the area of a rectangle is 85 centimeters squared. The width is 10 centimeters. What's the length? So sometimes you will know the area and you need to find the dimension of one of the sides. So what we're doing is working backwards. So we know that length, whatever it is, times by the width must equal 85 centimeters squared, right? So we need to find what number do we times by 10 to get 85. Now you might be able to think that off the top of your head. If not, you just say that the number is 85 divided by 10 because we undo timesing by 10 by dividing by 10. So what the number is that goes in the box is just 85 divided by 10, which is 8.5. So the length will be 8.5 centimeters. Then the area would be 85, okay? Let's try another question that's a little bit harder. So, the area of a square is 81 meters squared. What is its perimeter? So, to know the perimeter of a shape, as we did last time, we need to know how long each side is. So, if the area of a square is 81 meters squared, that means whatever the length is, if you square it, if you times it by itself, you get 81. So you have to think, what number do you multiply by itself to get 81? And that's just the square root of 81. So L, the length of the square, would be the square root of 81, which is 9. So if the area of a square is 81, it will be like this, a square that is 9 times 9, because 9 times 9 equals 81. So therefore, the perimeter would be 9 plus 9 plus 9 plus 9. 4 times 9. So it'll just be 36 meters. All right, now I will do parallelograms. So we've come across parallelograms before. So to remind you, they're quadrilaterals, so four-sided shape, and they have two pairs of parallel sides. They basically look like a rectangle on a slant. Although a rectangle is a type of parallelogram, we're looking at how to find the area of any parallelogram, even if it's not a rectangle. So, for parallelograms, apart from having two pairs of parallel sides, have two pairs of equal sides. So, the sides opposite each other, facing each other, are equal, okay? Now, the thing that makes some parallelograms different from rectangles is we might say, let's call this B for base, and we can call this W for width. Unlike rectangles, we don't multiply this and this together because it's on a slant. The area of a parallelogram is base times height, but remember, as I said before, whenever we see H in area, it always means perpendicular height, so it's the height at 90 degrees to the base. So we're talking about something that is 90 degrees to the base, so something like this. Okay, we need this height in here, not the slant height. So let's go through an example. Okay, so again, I apologize for my drawing. Okay, so let's say for this parallelogram, I'm going to say that this length here equals 10, and let's say this one down here equals 18, and this one here equals 13. So I want to find the area of this parallelogram. Okay, now what we see here is the base is the one that meets the perpendicular line. So if this line here, the red line, is perpendicular, then 18 is the base and 10 is the perpendicular height. This 13 is actually the slant height of the parallelogram, so we don't need it to find the area. We would actually need it to find the perimeter, but not the area. So the area of this parallelogram is just going to be base times perpendicular height, which is 180. Now, if the units, like centimeters, meters, aren't given, you just say it's units squared. All right, I hope you've enjoyed this video. Sorry it was a bit long. This has been the luckiest maths teacher in the world. Have a great day.